Continuing on with sample test 3, number 7 asks me to identify the open intervals on which the function is increasing or decreasing. When I'm looking for increasing or decreasing, my goal is to take the first derivative, find any critical numbers, and then set up a number line that I can translate into increasing and decreasing. So I start by taking the derivative g prime of x squared becomes 2x, negative 2x becomes negative 2, and the constant negative 35 drops out. I can factor out a 2 from this and make a 2 parentheses x minus 1. That gives me the only critical number, x equals 1, which makes this 0. Now that I know the critical number, I can create a number line. Only number I care about is 1. When I go back to this derivative, if I plug in something smaller than 1, let's say 0. 0 minus 1 is negative 1, times 2 is negative 2. All I really care about is the sign, telling me that this whole section is negative. If I try something larger than 1, let's say 5. 5 minus 1 is 4. 4 times 2 is 8, which is positive. So this whole section is positive. I now need to read my number line, basically by saying where I see negatives, the original function is decreasing. Where I see positives, the original function is increasing. So this function is increasing, starting at 1, going up to infinity. It's decreasing from negative infinity up until 1. For problem number 8, it gives us a function. It asks us to find critical numbers, increasing, decreasing, and relative min-max. All of this is tied to the first derivative. So the first thing I'm going to do is find f prime of x. 2 times negative 3 gives me negative 6x. The x drops off and I get plus 6. And then the 4 goes to 0. If I factor this, I can take out a negative 6. And that leaves me with x minus 1, which means x equals 1 is again my critical number. So when it says find critical numbers, the correct answer is x equals 1. I'm further going to use that to create a number line. When I try something less than 1, let's say I try 0. 0 minus 1 gives me negative 1. Negative 1 times negative 6 gives me positive 6. So this whole section would be positive. If I try something bigger than 1, let's say 5. 5 minus 1 gives me 4. 4 times negative 6 is negative 24. So this whole section is negative. I can now translate this number line into increasing, decreasing by saying it's increasing, starting at negative infinity, going up to 1. Decreasing, starting at 1, going up to infinity. When I look for whether there's a relative min or max, it depends what the sign change is. If I change from increasing to decreasing, a maximum will be created. If I change from decreasing to increasing, a minimum will be created. Here I change from increasing, heading up, to decreasing, headed down, which means in the middle there I had to have a highest point or a maximum. So there's a relative max at x equals 1, and then I need to find what the associated y is by plugging back into this original formula. To find f of 1, I would do negative 3 times 1 squared plus 6 times 1 plus 4. This becomes negative 3 plus 6 plus 4, which gives me a final answer of 7. So there's a relative max at 1, 7. As far as the relative min, there was no place on our number line where it was decreasing then increasing. So the relative min does not exist.